Welcome to this short tutorial to show a few basic steps in data cleansing to achieve a clean data file. My name is Ronald Gunnarsson. One of the first steps is to try and look for obviously incorrect values in your dataset. And let's start by looking for the variable smoker. So usually we start with clicking on Analyze, Descriptive Statistics, Frequencies, and then we find the variable smoker, click on the arrow to get it over in this box, and then hit OK. And when we look at the outcome, we can see that we have non-smokers. They're coded as a 0 in our dataset, but they also have the label non-smoker. Number 1 corresponds to smoker, and then we have one single observation where it's coded as number 9, and that is a bit suspicious. So let's go and find this number 9. So one way of doing it would be to go in the column for smoker and just scroll down, which you can do quite easily if you have a small data set, but if you have a larger data set, that becomes a bit tedious. So in that case, go down to Data and select Cases, and we click if, for example, let's find smoker. Yeah, click on the arrow to get it over. Smoker equals 9. Hit continue and OK. You will see that it pops up a filter on here, so we have sort of filtered out our data set. We can see here that most of the cases are filtered out. So let us find our number 9, our smoker labeled as number 9. Let's go to Analyze, Descriptive Statistics, Frequencies, and then pick, we have one variable called patient number, which is just a sequential number. And we can see that this single observation is patient number 558. That means we know where to look in our data file. So let's go down to patient number 558. Okay, this is patient number 558. And in the column smoker, we have the observation 9. So let's go back and check in the raw data, and once you have done that, we discover that this observation should actually be coded as a 0, which makes sense because 0 and 9 is very close to each other on the keyboard, so you may easily have pressed the wrong button. So let's change number 9 to a number 0. So we have fixed that problem. Let's remove the filter. So we just click all cases. OK, and you can see no observations are omitted, and we don't have a label here called filter anymore. So we have fixed one error in the variable smoker. The other observations were seemingly OK. However, if you have made any errors in entering a 0 as number 1 or the reverse, you won't discover that with this procedure. The only way to discover that is to do double data entry, so you get two files and then compare them. That's another process. I'm not going to talk more about that here. Let's take another variable. Let's take fever, descriptive statistics, frequencies, and we have fever. And we see for fever that fever not present coded as a 0, fever present coded as a 1, and again we have one irritating number 9. So we need to find that and check that against the raw data. So let's start by finding it. So we go to data, select cases, if, and let's remove smoker and add fever instead. So fever equals 9. And we again see we have our filter on. Most of the observations are blocked out. Let's now find this observation because we have our data set is larger than we don't want to look through all of that. And again, we put in our patient number, which makes it easier for us to find it. And it's patient number 445. So let's go to patient number 445, scrolling. Okay, so this is patient number 445. We can see that that is the only one that is not deselected. And in fever, we have a 9. So let's go and check in the raw data that we have, if it's a hospital chart or whatever it is. And then we find that, again, it actually should correspond to a 0. So we change it to a 0. So we have corrected that error as well. So let's go back, select cases, and again select all cases. So now we can see all cases are selected, no filter on. And let's proceed to the next variable. Analyze, descriptive statistics, frequencies, and let's go for gender. And remove patient ID. Click OK, and you can see that we have one female and another label. We have one person labeled as female with a lowercase f, 349 labeled as female with a capital F, and 218 as male. The computer will perceive this as 3 different genders, which is not what we want. So the easiest way is to find the female with a lowercase f and just change f to uppercase f instead. So let's do that. Data, select cases, if, gender equals see how it works. And again, try and find that one by looking for the patient number. It is patient number 570. Which is actually our last observation in our data set. Let's go to gender. Yeah, there we have it. And let's replace that with a capital F. Okay, we have changed that. Data, select case. I can just mention that I put a tag before and after female to indicate that this is actually a text variable, not a variable that is a number. It's a string variable. So let's go for all cases, and we should actually check afterwards that we managed to fix our problem. So let's have a quick look at gender again. And we can see that now we have 350 female with a capital F and 218 male with a capital M. And that is exactly how we want it to look like. So let's proceed with our data checking. Let's take another variable. Let's take date of birth. See how that looks like. So we can see they come presented in order. In this case we have formatted, so we have year and then month and then day. So it starts with 1905, which is possible, and then it goes up to 2012, which in our case is also perfectly reasonable. If we have a very long list, we may not want to scroll through all this list, then we can in the frequencies we can say that we want the maximum and minimum value, and then we get that here, and then we can ignore this long table, and we can see that it goes from someone born 1905 to someone born 2012. So that was okay. Let's proceed to another variable. We can take date of presentation when they had their consultation at the clinic, and again we want to see at minimum and maximum, and click OK, and then we will see that the minimum is 2012, 2nd of March 2012, which makes sense in our data set. And then we have the latest date of presentation is the year 2913, which is, it doesn't make sense. So the question is that one single extreme observation, or do we have a lot of them? And then we need to go down in this table to look more in detail. And the problem comes in the top end. So let's go to the top end first and have a look. Scrolling down, and we can see here that we have one date which is 13th of June, which makes sense, and then we have one single observation which is 2913 for year, April, and 28th of April 2913. So we want to find that case with 2913 to see and to check that against the raw data we have. To find the peculiar date of presentation, let's use another function. Let's sort cases, and let's move over date of presentation to sort by. Let's tick the descending and click OK, and let's have a look. And we can see that the lowest date comes first, and if you scroll down to the end, we have the peculiar date as the last date. When we check that towards the raw data, we find that it should be 2013 and the same month and day. So let's change that. Okay, now we've fixed that problem. So this was just a short tutorial of how to correct obviously incorrect values. Thanks for listening.